First, a kind of a correction on the last video. When I was talking about the ad hoc testing and all that, that is not a testing technique. That's a way to make a chip testable. So all that hardware that we added in this video, all that hardware was there to make the chip testable. It's not a test per se. The test would be putting a value onto the input pin here and watching what came out of the output pin here and deciding if your chip was broken or not. This method of making your chip testable means that you are you're improving its testability, and the field on how to make a chip easily testable is design for testability, or you commonly see it called design for testing, testability. Yeah, so these are more about designing a chip so they're easy to test rather than the actual test that's done to them. I mean, it's a combination of that, but understanding how testable chips are designed will help you create tests for those chips. So just a correction from the video. So on to the last digital topic. Well, not the last digital topic, but I'll come back to them after I make some videos on analog testing, is what a scan chain is. So far we've done chips that are made to be testable using the ad hoc method, but there's also a design technique that uses a scan chain. And what a scan chain is, this is not the final picture right here, but what a scan chain does is it has a pin over here, and you give an input serially, or you can do it in parallel, but in some way you put an input through a shift register. So this is a big long shift register, and it can go through the entire chip. And what happens is you shift in a value. Let's say you had, let's say it's a small circuit and you just have, let me clean this up just a touch. I'm going to draw it without having that extra, without using the scan chain, and then we'll add the scan chain in a second. So this is you know, individual blocks being tested here. But what happens is you shift in a value, and then the clock ticks, and that goes to the next flip-flop. Clock ticks, that goes to the next flip-flop. And then at that point, that first value that you shifted in is in this position. The second value you shifted in is here. Third value you shifted in was here. And what you want is you want the value here to be the value you want to put through this logic. The value here is the value you want to be put into this logic. The value here is the value to be put into this logic. So from that you can see that would go like this, go like this. We can get rid of that. And like this. Okay, so we're almost there. Now we have the value put into the combination logic when test is 1. So after you've shifted in the data, so you have your data for this block in this flip-flop register, the data for this logic in this register, and the data for this logic in this register. The next thing you do is then you turn test on and you run that through the combinational logic. And what you want to do is you need to get this value somehow. You either need to test it, analyze it right on the chip, or somehow pass it back off the chip. And for ScanChain, it doesn't do on-chip testing of that logic. What it does is it puts a mux right here. And this value goes in here. And this value, let's just do this. That didn't work very well. So I've got that mux, and then you've got that mux. And what happens is after you've shifted in the shift register, so this one would just be shifting. Let's call that shift. When shift is 1, then this works just like a regular shift register. But when shift is 0, the thing that gets loaded into this flip-flop is the value from the combinational logic. So you shift everything in, and then you set shift equal to 0, and then the result of putting this data through the combinational logic now, that's what comes through the mux. And the next time the clock ticks, this D2, this register right here, has the result of putting this value into the combinational logic. It goes in and it stores it in this register. Okay. And the same thing's happening here. The value that you wanted to have on the input of this combinational logic comes from here. And then the result on the next clock tick, the value in here gets overwritten by the result here. And this was the data for this combinational logic. And the result of putting it through this combinational logic gets put into this last register. And then you just shift out, then you turn this shift back to 1, so it turns into a shift register, and you shift this result out, then this result out, then this result out. So you shift in the inputs that you want to see, then you change the shift signal to 0, and all of the inputs get overwritten with results, and then you shift the results out. And that means that you also need to have, if you've decided to make this a serial shift register, then you only need one pin in and one pin out. But if you're doing it with parallel data, then you need as many pins as bits you've stored. That means this would be a register and you'd have as many bits stored here. That's how many pins you would need out. So out pins. And this is what a ScanChain testable a chip that has been designed for testing that uses a ScanChain. This is what it would look like. Again, it shifts the inputs it wants to give to the combinational logic blocks, and then it takes the results of those combinational logic blocks and overwrites the inputs into the registers and then shifts them out.